Electronics in Industry, organized by Department of Mechanical Engineering, SND College of Engineering and Research Center, Yavla. Friends, in today's world, technology is not just a tool, it's becoming a companion in our daily life. From automated cars to intelligent healthcare devices, from smart agriculture to advanced manufacturing, robotics and mechatronics are reshaping industries and redefining human potentials. And that's exactly what we are here to explore in this 1 week update. At this moment, I take a pride sharing about Institute, SND College of Engineering and Research Center, which is established in 2006, affiliated to Savitri Bai Phule Pune University and accredited by NAC B++ grade, and recently received an autonomous status from UGC with 52 well-equipped laboratories, advanced ICT tools, and strong vision to create multi-faced engineers ready to serve the nation and the world. Our institute is continuously striving towards the academic and research excellence. Our mechanical engineering department, since its inception, has been a hub of innovation with strong computational facilities and active professional bodies like ISHRE and MESA, making it one of the most vibrant departments on campus. We are blessed today with the support and vision of our respected management, Honorable Narendra B. Darade, sir, ex-MLC Chairman, Jagdamba Education Society. Honorable Kishore B. Darade, sir, MLC, Maharashtra State Chairman, Matoshri Education Society. Honorable Lakshman B. Darade, sir, Secretary, Jagdamba Education Society. Honorable Kunal N. Darade, sir, Secretary, Matoshri Education Society. Honorable Rupesh L. Darade, sir, Director, Jagdamba Education Society. We also extend our gratitude to our beloved principal, Dr. D.M. Yadav, sir, under whose guidance and encouragement this FDP is being conducted, and heartfelt appreciation also goes to our program coordinator, Dr. H. U. Pawar, sir, and Dr. Harshal S. Rane, sir, for their dedicated efforts. Before we proceed further, it is important to recognize and appreciate the esteemed advisory board of this faculty development program, whose guidance and support has been invaluable. Dr. A.G. Thakur, sir, Vice Chancellor, Sanjeev University, Kopargaon. Dr. G.K. Kharate, sir, Dr. Director, Matoshri College of Engineering, Nasik. Dr. D.S. Bormane, sir, Principal, AISSMS, Pune. Dr. S.D. Shir Bahadur, sir, BOS, ENTC, Pune. Dr. M.R. Sanghvi, sir, Joint Director, SNGB, Chandwad. Dr. S.B. Thakre, sir, BOS, Civil Engineering, Pune. Dr. Sanjay Devkar, sir, BOS, Electrical Engineering, Pune. Dr. P.A. Patil, sir, BOS, Mechanical Engineering, Savitribai Phule, Pune University. We sincerely thank all the respected advisory body members, board members for their constant encouragement, visionary inputs, and for helping us designing a program that bridges the academic with industry relevance. Their presence even inspires and enriches this episode. Now it's my proud privilege to introduce our chief guest for today's faculty development program, Dr. Sanjay A. Devkar, sir. Dr. Devkar, sir, is a highly respected academician and dynamic administrator with an illustrious career spanning 29 years in teaching, research, and academic leadership. Currently serving as a principal at SSPM's Sharat Chandra Pawar College of Engineering and Technology, Pune. He has held multiple leadership roles, including vice principal, dean academics, HOD, campus director, and director for admissions and placement across the reputed institutions. A versatile professional, Sir's expertise spans electrical engineering, data science, artificial intelligence, machine learning, energy audits, power quality, green audits, and environmental audits. He has been recognized with several prestigious awards, including the State Level Excellence in Energy Conservation and Management Award by the Government of Maharashtra, the Indo-Global Engineering Excellence Awards, and Outstanding Leadership in the Higher Education Award 2020. As a PhD guide under Savitribai Phule University, he has successfully guided many research scholars, while his own research contributions include patents publications in reputed SCI Scopus Index journals and innovative projects in smart grid renewable energy, electric vehicles, and AI applications of the engineering. Dr. Devkar has also represented on Board of Studies in Electrical Engineering at SPPU and BCNM University Jalgaon, contributing significantly to the curriculum design and academic policy making. He is also accredited energy auditor, IGBC accredited professional, and life member of IST and Institution of Engineers India. Sir has been thought leader in promoting green technology, sustainable development, and industry academia collaboration. His career reflects a perfect balance of technical expertise, academic innovation, and visionary leadership. On behalf of S&T College of Engineering and Research Center, Yavla, it is indeed an honor to welcome and introduce Dr. Sanjay Devkar sir as a chief guest of this faculty development inaugural program. We are truly privileged to have your presence with us today, and we are eagerly look forward to your inspiring inaugural address. Traditionally, every auspicious event in India begins with the lighting of the lamps, a symbol of wisdom, knowledge, and positivity. Since we are connected here through an online platform, let us celebrate this moment in a virtual yet heartfelt way. I now request our chief guest, Dr. Sanjay Devkar sir, along with Dr. Our beloved principal, sir, Dr. D.M. Yadav, sir, and coordinator, Dr. Hajit Pawar, sir, and Rane, sir, kindly grace this occasion by offering their virtual blessing, symbolizing the lighting of lamps. Let us all take a moment to close our eyes, reflect, and invoke the divine energy that removes darkness of ignorance and brings in the light of wisdom.
या कुन्देन्दु तुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमा आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदा जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्
Thank you so much, respected dignitaries, for gracing this inaugural moment with your presence and blessings. Why robotics and mechatronics? Because the industry today demands engineers who can think, design, and innovate beyond textbooks. This FDP will not only introduce us to the basic component of robotics, sensors, actuators, controllers, and softwares, but also to their real-world applications, case studies, and futuristic trends. At the end of this program, we expect our participants to gain the practical skills, explore industry collaborations, and most importantly, align our teaching and research to the actual needs of the industry. In short, this FDP is not just about learning, it's about transforming the way we look at the engineering education. So on behalf of S&T College of Engineering and Research Center, I once again extend a warm welcome to all our respected dignitaries, resource persons, faculty participants, research scholars. Welcome you all and industry representative. Let us come together, share ideas, ask questions, and enrich ourselves in this exciting journey of robotics and mechatronics. Now, every great event has a guiding force, someone who carefully plans, designs, and executes the vision into reality. For this faculty development program, that guiding force has been our coordinator, Dr. Harjit Pawar sir, Head of Department of Mechanical Engineering and Associate Professor at SND College of Engineering and Research Center, Yola. Sir has been instrumental in conceptualizing this FDP on role of robotics and mechatronics in industry, aligning it perfectly with the Atal Academy mission of enhancing faculty skills and bridging the gap between industry and academia. I would love now request our FDP coordinator, Dr. Hajit Pawar sir, to kindly brief us about the event, its objective, and roadmap map for the week ahead. Sir, the screen is yours.
Hello, thank you, sir. Good evening, everyone. It gives me immense pleasure to welcome you all on behalf of Department of Mechanical Engineering at SND College of Engineering and Research Center, Yeola. I, Dr. Harjit Pawar, Head of Mechanical Engineering and coordinator of this ATAL FDP on role of robotics and mechatronics in industry. On this occasion, I take a privilege to extend a warm welcome to our respected management for their constant support and encouragement. I would also like to thank our Honorable Principal, Dr. D.M. Yadav sir. Without his guidance and vision, organizing such a program would not have been possible. I also thankful to our chief guest, Dr. Devkar sir, and I also very thankful and welcome to our distinguished resource person who has taken time out their busy schedule to share their knowledge with us. And of course, a special welcome to all the our participants. Today, a very special occasion for us. We are conducting the Atal Faculty Development Program for the second time in our institute. The Atal Faculty Program on Robotics and Mechatronics. Let me briefly introduce what this Atal FDP is about. Atal stands for the AICTE Training and Learning Academy. It is an initiative by AICTE to enhance the teaching and learning ecosystem with our country by equipping faculty members with modern knowledge, emerging trends, and industry-oriented skills. The importance of such faculty development program can't be overstated. They provide a platform where academicians and industry experts interact, exchange their ideas, and prepare ourselves to better guide our students for the challenges of the future. This year theme is robotics and mechatronics is highly relevant. As we all know, industries are moving rapidly towards automation, smart system, and advanced manufacturing. Robotics is no longer an futuristic concept. It is already transforming the way of industry function. Mechatronics is the integration of mechanical, electronics, and computer engineering is a backbone of this transformation. For us, a faculty member, understanding this advancement is not just an option but is necessary so that we can shape our students to meet the industry demands and contribute to nation building. We all are fortunate to have with an eminent resource person. We carry a wealth of knowledge and experience in this field. Over the coming 6 days, means from 15 to 20 September, we will have an enriching schedule. There will be overall 13 sessions. They will cover the fundamentals of robotics and mechatronics, industrial applications, simulation and design tools, automation practices, as well as discussion in the future strength. I am confident that by the end of this FDP, every participant will feel empowered with new insight and practical approaches. Now, we will have our first session by the Dr. Hitesh Thakre sir on the topic of recent trends in automation and robotics. Then after Pratik Kakde sir, he is from out of India and topic is a CAE and virtual testing. Then number third session by the Pranav Lat sir on the robotics programming. Next session by the Mr. Kalpesh Patil on robotics system. Then next, Dr. A.D. Vikasar on robot communication protocol. Then number 6 session by Dr. Kiran Boresar, recent advances in additive manufacturing. Then next, Dr. P.M. Solanki sir on the PLC system. Then next, Dr. Bagul sir. Dr. Bagul sir have taken the 2 session interface robot and PLC as well as robotic applications. Then Mr. Anand on AI in robots. Then Mr. Vicky Vakre sir, IT-based automation. Then Dr. Sunil Kadam sir on Industry 4.0. Then last session by Mr. Sachin Patel, optimization of industrial robots. Friends, this FDP is not just about attending lecture. It is also building networks, exchanging experiences, and igniting new ideas that we ultimately enrich our teaching practices and research endeavor. All the participants to be actively involved, ask questions, and make the most unique learning opportunity. In last conclusion, I wish the program great success. Let us all move forward with curiosity, commitment, and collaboration, keeping in mind that we are preparing ourselves today to inspire and empower the engineers of tomorrow. On this note, I wish each one of you a very happy engineering day. Today is the 15th September, is the engineering day, and maybe spirit of collaboration and learning from the FDP continue to inspire us all. Thank you once again. A very warm welcome to each one of you. Thank you.
Thank you so much, Dr. Harjit Pawar, sir, coordinator of this FDP, for giving us such a clear and inspiring overview of this faculty development program. Your vision and efforts have truly set the right tone for the session ahead. Due to some emergency work, our principal sir is not available to share his views on this FDP program, but his wishes and blessings are with us. And now it's my honor and privilege to invite our chief guest of today's inaugural function, Dr. Sanjay Devkar sir, esteemed BOS, member of Electrical Engineering, Savitribai Phule Pune University. Sir has a torchbearer in the shaping electrical engineering education and research at the university level, ensuring that it stays relevant to industry and needs and global trends. His presence today adds immense value to our program. With great respect, I request Dr. Sanjay Devkar sir to kindly deliver your inaugural address and share your thoughts with us. Please, sir.
Hello, hello.
Yes, sir.
Can you hear, sir?
Yes, sir. Yes, sir.
Yes, 1 minute. Hello. Hello.
Yes, sir. Yes, sir. We can hear.
Yes. I'm really very happy to the SND College of Engineering Management Principals, Department of Mechanical Engineering for organizing such a beautiful Atal 1 week FDP on robotics and mathematics in the industry. So, in related with this, I will want to share my some views. The role of robotics in industry. The automation and repetitive task. Robotic replace human labor in monotonous, hazardous, or high precision task. For examples, assembly line in automotive, packing, welding, and material handling. Next area is the productivity and efficiency. Robots work 24/7 without any fatigue, increases throughput, reduces production time, and minimizes errors. Another area is the precision and quality control. Industrial robots ensure consistent accuracy in machining, electronics assembly, and various pharma applications. Vision-based robots support inspection and defect detection. Another area very important is the safety in industry. Robots handle toxic chemicals, heavy lifting, or high temperature processes. Collaborative robots combats assist human safety. Another area is the customization and flexibility. Adaptive robots with AI ML allows flexible manufacturing and mass customization. Industry 4.0 integrates robots with IoT, cloud, and digital twins. Now you have connected mathematics with robotics also. I think robotics and mathematics both are integrated. Without we cannot go ahead in this industry area. Now the role of mathematics in industry, modeling and simulation. Differential equation model industrial processes like fluid flow, heat transfer, and control systems. Simulation reduces prototyping cost. Another area is the optimization, linear programming and operations research optimize supply chain, logistic and reduces allocation. Robotics, path planning and scheduling rely heavily on optimization algorithm. Then data science and AI in industry. Statistical modeling supports predictive maintenance, demand forecasting, and quality analytics. Machine learning and deep learning, grounded in linear algebra and probability, drives industrial intelligence. Then another area is the control system. Control theory uses calculus, matrix, and Laplace transform to regulate robotic motion and stability. Then another area of mathematics is the computer vision and robotics mathematics. Geometry, trigonometry, and matrix help in 3D modeling. Matrices help in 3D modeling, robotic arm, kinematics, and camera calibration. Numerical methods aids in solving nonlinear equations, robotics, and applications. Then in mathematics and robotics, how is the synergy? Robotics cannot function without mathematics. Then in the kinematics, geometry and trigonometry. In dynamics, there is a differential equation. Path planning, graph theory and optimization. Machine vision, there is a linear algebra and probability. In AI/ML, there is a statistics and calculus. In modern industry, mathematics provide the brain, that is algorithm, models, and optimization, while robotics provides the body, that is the execution, automation, and precision. In short, I can say robotics brings automation, precision, safety, and efficiency, while mathematics powers the models, algorithm, and decision making behind them. Together, they are the backbone of Industry 4.0 and smart manufacturing. I think from my side, the inauguration of this 1 week faculty development program, I inaugurate. And thank you for giving me the opportunity to, as a chief guest, as well as to join this 1 week FDP program. Thank you.
Thank you very much, sir, for your insightful and inspiring address. Your words have not only encouraged us, but also set the right direction for the faculty development program. With this, I officially announce that inauguration ceremony of FDP on role of robotics and mechatronics in industry stands concluded. So I request all the participants to turn on your camera so that we can take a screenshot of your pictures. So it's my humble request to all the participants to turn on your webcam. Just hold on a moment. All participants are requested to turn on your webcam so that we can take a picture. All participants are requested to turn on your cameras. Still, few webcams are turned off. I request all the participants to turn on your webcam. Okay. So as we step into our first technical session, let us keep in mind that each session is a doorway to innovation. Robotics is now just about robotics, not just about the machines. It's about making life simpler, industries smarter, and society stronger. With this thought, I request all the participants to kindly stay connected as we now move directly into our first technical session. Now over to you, Professor Tushar Gujarati, sir. Thank you.
A very good evening to all present here. I, Professor Tushar Gujarati, Assistant Professor, Mechanical Engineering Department, welcome you all to the first session of ATAL-FDP. It is my great privilege to introduce our distinguished speaker for session 1 on recent trends in automation and robotics of this ATAL-FDP. We are honored to welcome Dr. Hitesh Thakre, an accomplished teacher, researcher, and consultant. Dr. Thakre is currently serving as an associate professor and head of the mechanical engineering department at SVKM's Institute of Technology, Dhule. With more than 18 years of academic, research, and consultancy experience, he holds a PhD in mechanical engineering from SVNIT Surat and is a BEE certified energy auditor, securing an impressive All India rank 4 in the Bureau of Energy Efficiency Examination. He is also a certified internal auditor for ISO 9001-2015, ISO 21001-2018, and a GHG accounting lead verifier for ISO 14064. He has also written the book Analysis of Vortex Tube and published several high impact research papers in SCI and Scopus Index journals. His research area include computational fluid dynamics, energy conservation, industry 4.0, and sustainable industrial practices. He has also contributed to consultancy projects and green audits for prominent industries and educational institutions, bringing practical value to his expertise. Dr. Thakre has delivered numerous expert talks on energy audits, Industry 4.0, automation, and research paper writing skills, making him an ideal speaker to guide us on the latest developments and innovations. We are indeed delighted to have Dr. Thakre with us today to share his valuable insights on recent trends in automation and robotics. So, on behalf of our institute, I request all participants kindly join me in extending a very warm welcome to Dr. Hitesh Thakre, sir. Welcome you, sir. So, I request you, sir, so kindly start the session.
Good evening, sir.
Yeah, good evening, sir. You can share your screen.
Okay, sir. So my voice is clearly audible to you.
Yes, sir.
visible?
Yes, sir, it's visible.
Sir, please confirm that my slide is visible to you.
Yes, sir, it's clear.
Yes, okay. So good evening, respected panel members and dear participants. I'm just going to share some views on recent trends in robotics and automation. Uh, just at the outset, I wish to declare that I am not an expert on the topic. I am just a student of this science. So that's why I have kept the title as Trends in Robotics and Automation, but a pragmatic deliberation. Whatever little understanding that I have about the topic, I am going to present in front of you so that uh, the audience gets acquainted with various dimensions uh, or various directions in which to think about certain technology. Particularly, this is necessary. Pragmatic deliberation is necessary when we are witnessing something called as AI boom in our daily lives, as well as industrial practices. So there needs to be a ground reality check whenever we are trying to either adopt a technology or reject the technology or include it in certain aspects of business operations or day-to-day life activities. So that's why the title is Pragmatic Deliberation. Uh, the outline of the presentation is very simple. First of all, we'll need to go through the relevance or need of the robotics and automation. Then we'll see what are the advantages, disadvantages. We'll have a discussion about the focused applications of this science. Just a few moments ago, BOS sir was the chief guest for the session. BOS sir was saying that the robot can replace human labor in so many applications. So we'll discuss about that. Then we'll also consider the energy consumption aspects of robotics. And then in the case of humanoid robot, glance onto that. So basically, a robot is a automatically controlled, reprogrammable, multi-purpose manipulator. Sir, just confirm what part of the slide is visible to you? Can you please confirm? Because on my this thing.
It's okay, sir.
Okay, just a second. I'll reshare it.
Okay, sir.
Yes, yes. So this is a definition given by ISO 8373-2021 that it is an automatically controlled reprogrammable multi-purpose manipulator which can be programmed for 3 or more access depending on the need of the application. And at the same time, it can be either fixed or it can be fixed in a place or it can be fixed to a mobile platform so that it can be used in automation applications within an industrial environment. Just here is a picture of ABB robots in motion, and next to that there are various types of robots. The audience can Google the applications of these various types of robots, how it is different from the SCARA robot or Polar robot. What can be these? These are the technical terms as per the standards specified, and they are very essential if we want to understand the technical terminologies. Being very honest, all these understandings are already mentioned in our textbooks or reference books or even research papers are available on the topic. But then, why are we focusing on this thing? That why the pragmatic deliberation? Being pragmatic means we are dealing with the problems in a practical way rather than simply following the theory or whatever is given in the book. Once we start to implement that, the uh, picture changes altogether. And that's why we need to have some pragmatic understanding of the technology. this is our general perception of a robot. That robot is generally used. We might have seen several videos on YouTube that in Amazon warehouse or in airport also robots are they are being used. They have always been used for packaging, palletizing, or lab analysis, or machine tending, somewhere in industrial assembly, welding operations, screw driving, or injection molding, gluing, dispensing, and welding operations. These general
Sorry to
perception.
disturb you, sir.
Yes, sir. Please.
Hello. Hello.
Yes,
Sir,
sir.
can you hear me?
Yes, sir. Please.
Sir, actually, there is some disturbance. The network issue is at your end.
Okay. Okay. So,
Bandwidth is somewhat low. Yeah.
so the screen is not appearing properly, sir. Hello.
Uh, your voice is breaking.
Voice is breaking.
Yeah, now it's
Oh,
fine.
No,
now
sir.
it's
No,
fine.
sir.
Yeah, it's fine now.
Okay. Okay. Thank you, sir. So this is our general perception of a robot, and this is how we have seen the robot in our textbooks. And after that, only when we pursue some higher study or research work in that domain, only then we come to know about the other dimensions of the robot. But the core question is, why today we are discussing, or why in today's age still we are discussing robot, even though it is a 30, 40, 50-year-old concept, from the simplest mechanisms to the complicated ones that we see today. I remember when I was pursuing my graduation or post graduation, there was some Honda Asimo robot, which was the highlight in the news. So, but still, today we need to develop an understanding about the robot. The reason is that we humans are a particular kind of fish. We are selfish kind of fish. We are very much selfish about improving the productivity, improving the uh, business operations, and ultimately improving the profits. And that's why we are studying these technologies even today. And that's why they are relevant even today, even if it is a technology of old ages. All the corporations, they are trying to reduce the cost of the production and improve the productivity of the workers or overall work environment, consequently increasing the profits. So that's why they are focusing on these technologies. But why now? Because now there is support from intellectual community in terms of hardware upgradation or in terms of software upgradation, the technical and technical feasibility and economic viability of such solutions. And that's why this particular science is gaining momentum. If we talk from a industrial perspective or from a market development perspective, uh, the industrial robot market is now booming at the rate of about 14.2%, as identified by Fortune Business Magazine. So, progressively, it is supposed to go from present value of about $20 billion to about $55 billion in 2032. And mainly, this is supported due to the rise in the logistics sector. We humans are becoming more and more uh, consumers. We are consuming so much, as it can be seen from our orders of Amazon, Flipkart, Zepto, Blinkit. And because of that, this technology has been benefited directly and indirectly. When we talk about the industry development, ABB has introduced a new IRB 1090 education robot, which has been particularly designed so that employees can be trained in industrial plants so that their employees can have a competitive advantage. Everybody has understood the technology game, that whoever has the better piece of technology will excel in the market. So that's why everybody is trying to train their manpower as well. Then, uh, when we talk about various applications, they can be pick and place, it can be welding and soldering, material handling, assembling, cutting and processing, as well as other applications. Pick and place is a very common application generally in a very large warehouses. Uh, this application can be observed. Particularly, this is also very useful in the case of casting industries, where the objects to be handled are either at very high temperatures or like in the investment casting business, the objects are very delicate and robots can do this duty with a very, just give me a second, with a very high precision. Just give me a second. Okay. So when we talk about the industry, apart from that, electrical and electronics, foods and beverages, rubbers and plastic, healthcare and pharmaceuticals, metals and machinery. When we talk about rubbers and plastic, the uh, polluting working environment in these industries makes day operations as well as previously there has been range of 10 kg. Now the range has been extended even more to, if we consider the area-wise distribution, mainly North America, South America, Europe, Middle East, and Africa, you can see that now these are being deployed extensively to cater to the dearth of manpower. At the end of the day, it's the profit that matters for the organizations. So they want to enhance their productivity by deploying a mechanism which will often rules and principles. And that's why the robotics is advantageous. First of all, it will reduce the cycle time. You can always optimize it. It is not prone to human errors. It will provide you with better production accuracy. Also, it will provide with better precision. Just a few moments ago, we said whenever there are repetitive tasks, the robots can really help the really replace the workers, because human mind has a tendency of making errors when the tasks are repeated a few more times. So, to achieve a better precision, particularly in an industrial environment where uh, mistake with the precision can cost money, as well as in certain scenarios, it can even cost life the people. So from that perspective, the robotics is beneficial. When the parameters of the production or the application are set, the robots are much better to to achieve the accuracy. Then the robots, when they are trained with the AI models, which are buzz nowadays, they can be very much helpful to ensure the decision making, the data which is available, instead of a judgment of the person, or instead of some cognitive biases, or the thought process of the person. So that rational decision making will definitely help in the improving the productivity of the organization as a whole. Robots can also help to overcome the human biological limitations, which is very much susceptible to the hazardous working conditions. For example, in recent times, there was development of a robot which was particularly developed for sewer cleaning of the human biowaste, because that's a very hazardous application. But at the same time, it is very important to maintain a general health or hygiene in the society. So the job of that robot was to simply clean the sewers, and the robot is not susceptible to all the dangerous gases which are the byproduct of such rivers, and which can be very much problematic for human beings, or even in mines. If there are coal mines and the mining work is going on, then robots can perform that task repetitively. In such situations, the environmental conditions are not very much favorable for human biology. Even in nuclear sites, for example, if people work in nuclear power plants, let us say a person has worked there for 25 years, then there have been several cases that people have developed uh, tumors or cancerous cells in their body due to the long exposure, even to minus amount radiations. So in such scenarios, robots can be hugely beneficial. Further, the robots do not ask for any kind of leaves. They don't know the difference between Saturday, Sunday, and Monday, and that's why they will not be asking for any kind of leave. They will not be asking for any kind of medical claim if it's accident on the shop floor or some mistake in production process. They will not ask for the provident fund, or they will not ask for the gratuity commitment from the employer. So this is just on a lighter note. But overall, on the basis of this, the robotics is advantageous for various industrial environments as per the scale of operation and nature of complexity. When we talk about the disadvantages, first and foremost, robots will have higher power consumption as compared to the general scenarios wherein human beings are operating in that industrial environment. Uh, this power consumption can mainly be attributed to their increased requirement of processing, and that we will discuss in subsequent slides as well. Their requirement for high level of processing, because they need to process a tremendous amount of data to decide the uh, further course of action or further course of movements. And this power consumption will directly put the strain on our uh, important fossil fuel reserves, or ultimately the environment as a whole. And that's why there has to be a particular judgment regarding the deployment of the robots. And this judgment has to take into consideration both sides of the coin. This energy consumption will result in accelerated depletion of fossil fuel reserves, excessive consumption, and stress on the grid as well. Second major disadvantage is particular to a highly populated country like India, where we are seeking employment for our youth or for our citizens, but at the same time, a robot is very much capable of replacing the human labor, particularly if the tasks can be automated or they can be programmed due to their repetitive nature. In such scenario, the uh, deployment of one robot can create unemployment for several people. And this is happening at a larger scale. Its application might be immediately justified, uh, for example, in countries or in the US or allied countries, wherein the population is not very high. The people are not available. Several even domestic chores people have to take care by themselves. So in those scenarios, robotics can be hugely helpful. But in a populated country like India, it needs to be judged based upon various factors. Then the next concern will be regarding the maintenance of such robots, whether we have the technical capability as well as material availability for that particular advanced technology. In that case, if any organization has deployed the robots for the productivity improvement, but at the same time, if the maintenance support is not available, then continual function of such system will become difficult. And at the same time, it will incur a huge maintenance cost for the parent organization. Because then in that scenario, if the maintenance is not carried out well in time, definitely the production is going to hamper, the business process is going to hamper because of this. Now, we'll be talking about the focused applications of this technology. Definitely, it's a very good technology, but then there are some particular applications wherein it can be immensely helpful, like stacking the products in the warehouse. So, this is a repetitive task, as well as it might require in a warehouse. There is a concern of the ceiling height. So, to reach such heights, it might be dangerous for human beings. In those cases, robots can be immensely helpful. Even forklifts are useful for this purpose, but then robots can always improve the accuracy of this stacking process. Then sorting of parcels and packages that we see in the airport. This is one of the dedicated functions that can be achieved by robots. Then welding of critical components. We have seen one such robot in one of the vendors of John Deere, right here in Nasik itself. That a component is critical in the sense that the welding angles are very deliberate, and they are very important from the strength perspective for that particular component. So, if manual welding is deployed in such case, then the production cycle time of that particular component uh, is higher. But instead of that, if the welding is carried out with the help of a robot, then the production cycle time of about 1 minute gets reduced down to 33 seconds or so. So that's almost half of the cycle time that we are talking about. And the same robot, that same robotic arm, within the next few minutes, can weld 6 to 7 components. And so ultimately, it's a huge gain in the productivity. And but and additionally, from a human perspective, whenever that component is welded, toxic fumes are generated. So the welder or the person in contact with the weld has to inhale those fumes and suffer with the health consequences. So these problems are avoided with the of deployment of because of deployment of this robotic welding arm. Then the next important application, the cleaning of hazardous areas. This is the application that I previously talked about, that particularly cleaning of sewer lines, wherein there can be a danger to the human life if a human being is exposed, if the fellow is having a prolonged exposure, to such hazardous environments. So there the robot can perform really a good job. Next one is a mining. Yes. Uh, so just give me a second. Okay. So particularly in the case of mining operations, there is one particular case that whenever there is a coal mine, so methane is usually in the vicinity of such a mine, and it creates a dangerous working scenario for the people inside the mine. Ventilation is very ventilation is very much inappropriate. It is very much insufficient for human beings. The working conditions are not good. The heat is there, temperature is there, humidity is there. So in such scenarios, if instead of a human being, if we have deployed a robot, then definitely other concerns are eliminated and the productivity of that mine can be improved. Then the sixth application, which I mentioned previously, the handling of particularly investment casting, which are very costly objects. At the same time, their dimensional accuracy cannot be compromised due to their intricate nature. So in such scenarios, the robot can be having a focused application. This is one particular application wherein in the old days, uh, the ladle of a melting furnace, it was being handled by human beings. Once again, the working conditions are not very much humanitarian, and they need to handle a very risky job. So such kind of uh, pouring operation or handling the ladle, these kind of operations, they can be taken care by the robots. Yes, this is just a picture of sand casting uh, or that sand core from an investment casting factory. Now the robots are being focused so that the manufacturing ecosystem can be disrupted or it can be affected. So machinery industry over the period of time has followed various trends. Like the first one was this disruptive technological trends in the form of um, additive manufacturing through 3D printing, the generation of new materials or e-mobility. Now the growth patterns are slightly shifting. There is an increasing competition from the Asian players. Previously, China was a major player in the manufacturing industry. Now it is also being compensated. So a few years ago, it was also Bangladesh, and now it is Vietnam, Indonesia. They are taking a lead in this manufacturing environment. The organizations themselves want to transform so that they are able to provide more flexibility, agility, and custom at the same time. The customer needs to be very much satisfied from the services, the products as well as services. The digitization is happening at a very huge pace due to the industry 4.0 as well as internet of things, which are the enablers for the future hardware cells and new digital businesses. So such digitization always needs a speedy supply chain system that can be accelerated through these robotic inventions. The customer requirements are changing day by day. The customer is being offered the customer is being offered with several um, options if the fellow is ready to spend money. So the solutions are needed at a fast pace instead of several customizations in the machining. And at the same time, the machine handling needs to be intuitive, which means with higher precision and with least possible amount of errors. Out of these, the growth patterns and this increased pace of digitization are the focus areas. So robotic and automation can definitely supplement these requirements due to their higher possibility of delivering accuracy, as well as they are very much agile. They are very much flexible. You can put them in any working environment. You can reduce the time of their training or time of their coding, their adaptability to diversified working environments. So even if these two strong trends they play very well, then still the manufacturing ecosystem can be disrupted. It can be shifted to the higher dimension. One of the examples is this, that robotic coal mining is gaining so much of momentum, as we can see from the number of total patents which are being issued to these organizations. The most prominent one being the Komatsu, then followed by Sandvik, T&D Science and Technology, Caterpillar, China Energy Investment, Shaanxi Tyndall Mining Machinery, and then Shanghai Mining Equipment Technology, TR and Company, Famer Group. So these organizations, they are aggressively working on robotic coal mining to reduce artisanal mining as much as possible. This is beneficial from both a market making perspective as well as the humanitarian perspective, so that the same manpower can be utilized somewhere else with the improved skill sets. Now, still the question is there that why the robotics and automation now? There are mainly these momentum factors. There is surge in investment and innovation. The robotics sector is attracting significant investments as compared to the past progress. Then AI foundation models as robotic brain power, they have been developed, and more importantly, they have been supported due to the hardware which is being developed by various organizations such as NVIDIA or AMD. So these hardware breakthroughs have helped extensively to accelerate the mobility and dexterity of these robots. Then these robots have very nice compatibility with the human-centered spaces, such as even nowadays Tesla is working on domestic help robots, which will be able to help older people in the home whenever their loved ones are not nearby. Discuss them one by one. The first one is surge in the investments and innovation. If we simply look at the market capitalization of S&P companies, out of that, there has been a huge gain in the market capitalization of AI-focused S&P 500 companies. Even the startups which are focusing on the theme of robotics, they have been receiving significant amount of funding over the period of time, and it has surged significantly. When we talk about the foundation models, they help with generalized understanding, multimodal integration, natural language interaction, perception and reasoning, and adaptability and generalization. So, when we consider these aspects, as the working environment of the robot becomes more and more unstructured as compared to the environment in which it was trained to work, it strongly needs the support of these AI models so that it can learn from the environmental variables and afterwards deliver a solution which is suitable, which is sensible for these unstructured environments. The robot may get trained in the lab, but it might be subject to the working operations, which are very much unknown to the lab training. So there has to be there has to be adoption, and learning curve needs to go forward in this case. If we talk about the complexity in the housing environment, the complexity is not much. Degree of observability is high.
Hello, sir. You are not audible. Hello. Sir, you are not audible. Hello. Dr. Thakre, sir, you are not audible. Hello. Dear participants, please stay tuned. There might be some network issue at speaker's end.
Hello, sir. Am I audible?
Yes, sir. Now it's audible.
Yes, sir. Yes, yes. I got disconnected. I got disconnected. Problem on my side. Second, I'll share my screen once again. Is it visible?
Yes, sir. It's visible.
Yes. So we were talking about uh, this degree of complexity. These AI models or foundational models are very much helpful to, in general, train the robots so that they can cater to various unstructured environments as well. Because even if we consider the case of basic household, still there are very much uncertain parameters which need to be tackled on a day-to-day basis. And the complexity, the uncertainty improves as we change from one application to other application. There can be various large language models, or uh, there can be various this vision models, or there can be multi-mode models which are facing multimodalities. LLMs can simply function on the modality of text, and so that it can achieve state-of-the-art performance for language-based tasks, such as the models that we have today, ChatGPT 2, ChatGPT 3, 4, even to some extent the recent one, ChatGPT 5, which is actually downgraded version of a previous ChatGPT. Then judging about the image, like the classification, segmentation, object detection of the image, models are available for that. For other modalities, such as vision language, means if the robot is subjected to combined input of images and text, such as captioning the image as well as answering a visual question, then the model needs to be enhanced and improved. There can be language and audio kind of modality, wherein the robot may need to encode the sound, and afterwards that needs to be processed so that the robot can deliver the desired output. The robot might need to take data from various sensors, even heat maps or skeletal movements, so that accordingly the multimodal learning can be completed and tasks can be executed. So, in essence, actually, whenever we are talking about robots, we are not just talking about a mechanical assembly. We are also talking about the brain behind the mechanical assembly. The foundational models, they are getting stronger day by day. So progressively, they will be assisted by deep learning technologies and then generative AI technology. Consequently, that AI and ML will take over, and of, after some time, the robots can become autonomous It will be so good in learning and training itself that its applicability can be enhanced. This cannot happen without the hardware breakthroughs. What happens is, what happens is, whenever the robot has to process such uh, humongous amount of data or such complicated data, then that computational power should be available with that, because whenever robot is subjected to real life environment, he might be bombarded with several variables from various sources. Sources may be known or they may be unknown. There can be sound, there can be visual input, or there can be commands received from its operator, or there can be decision making requirement based on the situation. So for this purpose, the hardware breakthroughs are very much necessary. Without a stronger hardware, that software and the processing and the computations,
Excuse me,
they
sir.
are
Hello.
not possible. Yes, sir.
Sir, if possible, can you please
Make it full screen.
zoom the screen? F5, please.
Make it full screen.
Sir, okay, okay,
Slideshow.
okay, okay. Is it okay?
That's fine,
Yes,
sir.
sir. Okay, okay.
Okay. So one of the examples of this is the recently developed uh, this processor by NVIDIA. Previously, they had this NVIDIA Orin, which had a this operating of 275 tops. Now, can somebody from the audience please tell me what the tops is? You can even Google it if you are on the machine.
Tetraflop, sir.
Yes. So, can somebody from audience tell me what is the physical meaning, the practical understanding about the tops?
Tera operations per second.
Sorry, please come again, sir.
Tera operations per second.
Tera operations.
Trillion.
Okay. Achha, trillion operations per second. 1 second. Okay. So those many operations they need to be done if the robot has to perform productively, if it has to process all the data. So even the NVIDIA Orin, it was 8 times more efficient and effective as compared to the last generation for multimodal AI interface. Whenever AI is running on these devices, it will need this kind of support. So now the recent one, the model which was launched in August itself, the last month itself, now it is delivering up to 2070 speed for the AI computation. It comes with your 128 GB memory with configurable power up to 130 watt. So again, it's a 7.5 times higher computational power than the previous version. And in terms of energy efficiency, it is again 3.5 times energy efficient. So due to availability of, this is just an example, there might be several other examples for several other applications. So in this case, if such hardware support is available, then definitely the robot can function the multimodal tasks. This is one example, and again, it's a recent example from just 2 months ago. It came into picture. There is a Atlas robot which is developed by Boston Dynamics, and Boston Dynamics was actually acquired by Hyundai. The robotic division is working on robots which can be properly deployed in the automobile assembly plant. And the in general overall investment is about $21 billion, which is humongous. These robots were tested in the month of July this year in the Georgia plant of Hyundai. This particular innovation has been promoted mainly due to the tariffs imposed by Trump on the foreign products. In general, the Hyundai as a corporation has decided a target of about 300,000 vehicles per annum to be manufactured with simply solely using this Atlas robot. That's how effective this robot is. Similar robots are also developed by other companies or other organizations, and but they are catering to different applications. This one particular Atlas robot, it is supposed to function in this assembly environment in the Hyundai's premises. And this is just a glimpse of some advanced robots like Tesla Optimus Gen 2, which is mainly focusing towards the home automation and somewhere in the manufacturing assistance. But the pricing of these robots is again on a higher side, which is very much expected. Then we have the Atlas that we discussed just now. After that, we have our robot from Unitary Robotics, and the function is directed towards the logistics and service sectors. While developing these robots, the focus was again on the agile and cost-effective performance. Then Agility Robotics has developed that robot named as Digit, which is mainly for the urban navigation and logistic applications, having a payload capacity of 15 kg. These are just four indicative examples, and others can always be found online. One important aspect regarding the sustainable development will be the energy consumption in robots. As of now, the robots are being subjected to a variety of applications or the variety of operations. So that's why estimation of their exact energy consumption is very difficult due to variation in the scale and complexity. But still, the back end of the robots, because at the end of the day, robot is a hardware which is functioning through the directions from its brain, which is nothing but software or its AI model. So at the end of the day, even if there is a domestic help robot, that device is going to capture the data, it is going to process the data, or it is going to need to store the data, which is being collected on a day-to-day basis, so that future decision making can be improved or enhanced. So that's why this is an important aspect whenever, particularly when we are facing such a shortage of energy in our day-to-day life operations. So that's why this becomes an important aspect, whether it is really justifiable or not. So if we see that the change in the perspective that International Federation for Robotics has observed, if we focus on the sir, please confirm that this zoom in is visible to you, and that I have zoomed in on one
Yes,
side
sir.
of the picture.
Yes, sir.
Yes, sir. Yes.
Yes. Yes. So this in 2023, the top most global robotic trends were related to energy efficiency in the robots, uh, the nearshoring of the robots or easier to use, AI and digital automation, and second life for industrial robots may be a part of circular economy. And then in 2025, there is advancements in such trends like physical analytic and generative AI, or focusing towards the single purpose humanoids. The robots will which will appear like humans, and they will be dedicated for some particular task, just like Hyundai's Atlas that we saw a few moments ago. Then sustainability and energy consumption is a primary focus. The new fields of business and customer segments which can be taken over by robots by replacing the human labor, and whether the robots can help to address the labor shortage. So these are the key trends as identified by International Federation of Robotics. So in that they have given a very significant emphasis on sustainability and energy consumption, which will be arising due to the adoption of robots. Now, the energy consumption in robots. it is not impossible, but as of now, it is difficult because of the variation in the speed that the robot is with which the robot is moving, the payload variation or the type of end effector used, how complicated the motion path is, and the amount of force which is being applied by the robot during the performance of the task. At the same time, like I said, this is the hardware part and this is the software part or the brain part. The AI which is running that robot or the code which is running the robot or the data collection, if it is happening, then the model training, inference and deployment, infrastructure for data center, as well as particularly cooling requirements to ensure the uh, efficiency of the chip or the hardware. All these are going to consume tremendous amount of energy. Particularly in this, if we see, when we are talking about a simple robot, it is one important part of the AI infrastructure. So right from the extraction of the high purity quartz sand, converting to silicon wafer, then lithography, converting it to GPU data center, and then training the AI models through software coding, and then it's multiple applications such as physical AI, predictive AI, computer vision, or generative AI. So the uh, robot itself is one element of this AI infrastructure. So it is going to get affected whenever this AI infrastructure is susceptible to energy consumption. If we observe the energy consumption trend, so the cost of GPU computation has progressively reduced than its predecessors, while the model training size it has improved consistently, and especially after COVID, due to improvement in the hardware support. Sir, sir, due to hardware support, there is an improvement in the model training size index. Apart from that, we can also see that more and more firms are using AI. Maybe it is for process automation or for robotics or data analysis, language generation, language analysis, or for various business functions such as R&D, ICT security, logistics, production, marketing. Progressively, these consumptions are going to increase. So that is going to put a stress on the natural resources, or it is going to initiate the accelerated depletion of these fossil fuel sources. One of the appreciable initiatives is by ABB. Actually, ABB has about 13 to 15% global market share in industrial robotics. So they have developed certain ecosystem wherein the robot users or the organizations can monitor the energy or benchmark the energy consumption, or they can optimize the energy consumption of the robot, wherein they claim that about 30% energy saving is possible when their recommendations are followed by the organizations. Okay, I think my screen is visible. Just wish to show
Yes, sir.
one. Yes, I wish to show one small video of today's actually our industrial visit. So this is one which is in a casting industry, and it is simply involved in a pouring operation. Now uh, these are the these are the storage furnaces wherein liquid metal is kept, and so that it can be put in the required application. Now it is being taken by the robot and it will be poured in the mold for that particular product. It's a simple casting industry in India itself. So this is a high temperature working environment, and now that job is taken care by robotic arm. The organization already has deployed 5 robots 3 by ABB, 2 by Kawasaki, and they are planning to put in more and more robots. This is a gravity die casting operation. I hope the video was visible to everyone.
Yes, sir.
Yes. So those are my 2 cents. I'm thankful to Dr. Yadav sir, Dr. Pawar sir, and Dr. Rane sir for providing me with this opportunity of sharing whatever little I knew about the topic in front of this eminent audience. Thank you.
Okay, sir. So from audience end, do you have any queries or questions? You may ask. All participants are requested. If you're having any queries, you may ask. Okay, so I think there is no queries from audience end.
Yes.
Okay, so a heartfelt thanks to Dr. Hitesh Thakre sir for such eye-opening session on recent trends in automation and robotics. The way you explained the concepts and the connected them with the real life applications has been given a plenty food of for the thought. So I now request all the participants, so stay tuned for the next session. And sir, I would like to add some request that if you could share the presentation with us, so it would be really helpful for everyone here. Having those slides will allow participants to go back, reflect on the points, and make the most reach and information that data you have shared with us today. So I'm sure it will be a great source for everyone for the future learning too.
Yes, sir. I'll do, sir. I'll share. I'll share.
Okay, sir. Thank you so much, sir.
Yeah, thank you, sir.
Yeah, thank you. So moving on to the next session. So it's pleasure. Okay, so for next session, we'll be joining after 10 minutes exactly. So take a break and get back to the platform at 8 p.m. Okay, so we'll take
Excuse me, sir.
yes, sir.
What is the procedure for attendance and feedback, sir? After every session or day-wise? Am I audible, sir?
Yes, sir. So attendance will be monitored by this Zoom platform, and also day-wise feedback will be provided on the WhatsApp group. So you need to feel that feedback, and parallelly we will monitor the attendance from Zoom platform. So it's a request to all the participants to join the Zoom meeting so that we can monitor the attendance. Not only just by filling the feedback form, we will count the attendance. We need to have the record from Zoom itself. So we'll take a short break of 20 minutes, and exactly at 8 p.m. we will start the second session. So thank you so much for attending the session. Thank you.
Thank you, sir.
So, hello everyone. It's pleasure to invite our today's session 2 speaker, who is a distinguished speaker, Mr. Pratik Kakade, a seasoned professional in the field of CAE, crash and safety pedestrian protection and product development, who has made a remarkable contribution to the automotive industry over the last decade. Mr. Pratik is currently working as a CA analyst at Jaguar Land Rover UK, where he leads the Magna exterior CA team with a focus on a pedestrian safety, front end design, and safety solutions for the electrical vehicles. His expertise covers the explicit and implicit CAE simulation, safety systems, validation, concept development, and proof of concept modeling for some of the most advanced vehicle programs in the IMEA, USA, and European regions. Before joining this Jaguar Land Rover, he worked as a technical lead at Henkel RLE, the Mobility Alliance, Pune, where he specialized in structural lightweighting and offered innovative engineering solutions for the weight reduction through adhesive inserts and reinforcement patches, contributing to improved vehicle performance and efficiency. He also served as a senior CA analyst at Volvo Trucks in Bangalore, where he was deeply involved in the pedestrian head impact methodologies, side and rollover crash simulations, battery integrity for EV trucks, and ECU collaboration studies. His work ensured compliance with Canadian safety standards while supporting the development of safer electric trucks. His journey began at Tata Technologies Limited, Pune, where, as a senior engineer in CAE, he worked extensively on head impact, roof crush, luggage retention, and frontal crash simulation, delivering simulations to global automotive leaders like Volvo and JLR. Academically, Mr. Pratik is equally accomplished, holding a master's degree in design engineering with an outstanding CGPA of 8.27 and bachelor's degree in mechanical engineering with a consistently excellent performance throughout his career. His passion for research is evident from his publications in the reputed international journals, including works on the crankcase crankshaft analysis, as well as studies on crankshaft failure mechanism. In addition to his technical skills, Mr. Pratik is proficient in leading CA tools such as LS-DYNA, HyperMesh, ANSA, and OSIS suite, and possesses strong capabilities in project coordination, product lifecycle management, and cross-functional collaboration. What sets him apart is not only his deep technical expertise, but also his technical leadership in the agile and scrum practices, his ability to bridge the gap between design and manufacturing, and his vision for engineering safer, lighter, and more efficient vehicles for the future. Today, as a part of this faculty development program, he will share his valuable insights into automotive safety engineering innovations in crash analysis and evolving role of engineers in addressing the modern challenges of electric mobility and pedestrian safety. So let us all join together in giving a warm welcome to our speaker, a true innovator and role of model for inspiring engineers, Mr. Pratik. Welcome, sir.
Thank you, Mr. Rane. Thank you, sir. This was really great introduction. I mean, I really thought like, who were you talking about? Was it actually me that you were describing? A really huge compliment, and thanks for that. Good evening,
Yes.
everyone. I'm glad that I've been given this opportunity to explain my expertise in C and virtual testing to you guys. Thank you for that. And good evening, everyone. I hope you have had dinner, and I don't want to bore you to sleep by just showing some random presentation. So let me give a brief about what I am trying to explain you today. So to start with, let me share my screen. 1 second, and do let me know if it is visible for you guys. Is this visible now?
Yes, sir, it's visible.
Okay, thank you very much. So from last 4 years, I've been working in crash and safety systems in JLR. And before that, I was still in the, I mean, I have been only working in crash and safety from the moment I left my engineering. So that has been my core career, I would say, that I was only embedded in the CAE systems. And because of that, that's the reason why I'm choosing CE as and virtual testing as a topic, which is slightly different from what the theme of this session is. I think it was mostly on robotics and mechatronics, but I would say CE is also quite good and important in today's world with respect to automotive engineering. So as a mechanical engineer, everyone aspired into automotive field. They want to know more about cars. They want to buy cars. They want to drive cars. There are a lot of passion about cars in general, and most of the automotive industries are supported by other industries. Like there are so many aspects of mechanical engineering being used in automotive. That we have tire systems, we have different electronics, we have softwares, etc., which in a way supports a lot of industries in our country as well as in others. So my focus would be mostly on the automotive and specific to crash and safety. Since it is a sensitive topic, apart from the fact that it is company data that I can't share mostly, so I have tried to give few details which I could share with you, and I'll try to explain most of those bits orally rather than going through the words in there, so that you don't bore yourself and crash your heads into your system. So let's start with what exactly is crashworthiness. And crashworthiness is something that, for example, if you are a passenger in a car and you come up, God forbid, but if you come up with an accident, the intention of crashworthiness or the concept of crashworthiness is a person who is in the cabin of the car, nothing should happen to that person. A car can be damaged, but nothing should happen to the person. So that's the intention of crashworthiness. And the philosophy of crashworthiness goes to our most basic principles of physics, and it is all stress, strain, energy, etc. Those basic principles is what drives our automotive crash and safety department. And uh, we have been hearing from childhood that we need to clear our basics, we need to have our basics good. So yes, that is really important. We need to know all our basics, which we have studied in engineering in school, and that's what is used everywhere here in an advanced way, but it is all the basic principles that we do now. um, Going to next slide. So crashworthiness, main intention is the cabin should not crumble, but anything outside or inside outside the cabin can crash when if it hits a rigid part or it's another vehicle. So to do that, we have to manage the energy. And in this case, just to ask you a question, for example, a car, it is moving at 5 kilometers per hour and hits a wall, and there's another car who is moving at 10 kilometers per hour and hits the wall. So 5 kilometers per hour and 10 kilometers per hour. The energy difference between those two, what do you think? How much would be the energy difference in the 5 kmph and the 10 kmph? Would it be twice? How much? Can anyone just answer that? There is no wrong answer in there. You can just let me know. It's okay if you don't know. That is also fine. But I would expect people to engage in this discussion. Okay, I got one answer is twice. Any other answer? Manoj Thorat mentioned twice. Is everyone with the same thing? You can just react yes if you're happy with twice. Avinash Bagul said 4 times. Surya says yeah. So yeah, Avinash, Dr. Avinash, yeah, that's exactly right. It is 4 times, because what energy would be in that case? It's the kinetic energy, and we know what the formula for kinetic energy is. It is 1/2 mv square. So we have to square the velocity. So the difference in that case, it's not twice, it's 4 times, because we are squaring the two. So if it is 5 kmph, we square it, it's 25. Whereas if it is 10 kmph, we are squaring it, it is 100. So it's 4 times the difference. So even small change in the velocity, you have a significant impact in the energy, and that energy you need to manage in the front structure of the car. So that is really important. So the higher you go with your velocity or with your car, it is the square of that velocity that you need to manage with. So this is what crashworthiness is all about. And most of the safety system works in a way that it absorbs those kind of energy. There are regulations that have been put in place in each country, which works with those kind of energies, and they ask the manufacturer to design car for certain loads, certain velocities of car if they are impacting. So the next thing is why it is important that we need to look into safety systems. Generally, I have seen most of the people, they don't wear seat belts. Most of them people, if you're using bike, you don't wear helmets. And why is that? We are not much aware about our own safety. And this is quite old. And this is, I guess it is 4 to 5 years old, but you can see nearly 1.3 million people die in road crashes. $5.8 billion is spent on road crashes cost. You have around 1,000 people under age of 25 who die in road accidents. 20 to 50 million people are injured and they are disabled permanently throughout their life. And this is really important that we need to look at, that our crash, the awareness regarding how safety is important in our life, how the speed limits are important, why these regulations are put in place. This is the major reason. And looking at India, there are a lot of automotive companies that are coming in. There are a lot of cars that are on the road. The roads are not getting wider, but there are a number of cars that are coming on the roads a lot. So there is a high chance that this risk factor has been increasing day by day. And that's the reason we have few regulations. So in that case, we have a seat belt reminder. We have a lot of safety features that are included in our vehicles. And that is really important because of these reasons. So if we look into crash and safety, there are two types of safety systems. One is active safety and the other one is passive safety. Uh, so just to describe how active safety works is, in case of active safety, these are all the features that comes before the accident happened. These are features that avoid the accident in the first place. You have all those systems incorporated in your car, so which would make sure that you don't go and hit something, or there won't be a case of accident. Whereas passive safety is something that in case the active system doesn't work, or in case the active system has failed, or you don't have any such system that would prevent the scenario you are in, passive safety makes sure that in case of crash, the occupant inside the car should be safe. So all those features that protects the occupant inside the car is considered as passive safety. So uh, can anyone give an example? What according to you is active safety? Any examples of active safety that you know or you must be using? You can chat, you can talk as well. If you want to unmute and speak, that's also fine. Seat belt. No, that won't be into active safety. ABS, yes, it would be in active safety. And yes,
Yeah.
yeah, ABS is into active safety, correct. Anything else? Similar to ABS, there are a lot of ADAS, yes, ADAS is in active safety, correct. Any other examples? Anyone have any suggestion? Airbags, no, airbag doesn't prevent an accident because it deploys, if you know an airbag, it deploys only once the accident
Handbrake.
happens.
Handbrake.
Handbrake, in a parking state, yes. But what I would say is when the car is driving, you won't use your handbrake. So in a driving condition, when the car is moving, what are the active systems? Yeah, in a park condition, yes, you can say in a way that, okay, handbrakes is stopping the car from rolling down or doing anything. But this is mostly with respect to a moving car. Adaptive cruise control, yes. Sensor for prevention of an accident. That's a little broader answer, but yeah, it those sensors are like adaptive cruise control. Okay, there is one more or transducers. No, I'm looking for specific systems that are already in place in the car. EBD, yes, correct. No, bumper isn't. No, brakes are not into active safety. Okay, that's great. A lot of responses. Really appreciate that. Let's go to next slide for all the systems of active safety. So these are all that you have considered as an active safety. Anti-lock braking system, somebody has already mentioned. traction control system. If you are moving on a wet surface, the tire try to there is an EDU system that controls the rotation of tires, which doesn't let you slip on a wet road or a muddy road. Stability control, cruise control, lane assist, steering control, suspension control, road sign detection, intelligence, speed assessment. So these all come into active safety. Hope everyone is aware of these. Yeah, change of headlights according to the road turning. Yes, correct. That is also good way. Yes. Now, what would be an example of passive safety? And some of them have already answered few. That is, seat belt was one of those. Airbag was one of those. What are other passive safety systems that you consider, like whether if the car is into accident, that prevents the occupant from getting injured? Crumple zone, correct. That's good. Engine drop, yes. Any more? Body frame, yes. But there are certain, not complete frame, but there are certain parts in the frame which are used to do that. Reinforced vehicle structure, okay, yes. In a way, yeah, that is also passive safety. That's good. So now just out of curiosity to ask you guys, we in the new, if you have bought a new car, when you start a car, the car beeps until you put in the seat belt. It asks the seat belt notification. The car won't stop beeping until you put on the seat belt. I've seen most people that they'll just keep the seat belt connected, and they will sit on top of it but not use it. Now, I'll give you two scenarios. In one case, a person is not using a seat belt, that is, it is just plugged in, but he's not using it. And then airbag deploys when he hits the flat wall. And there is another case where the person is not using a seat belt and there is no airbag as well. So what are the cases? Which one would be more hazardous? A person without seat belt and airbag, or a person without seat belt without airbag? First one, that is person without seat belt plus but have an airbag deployed. Okay, that's a good answer. Amit Karvind answered. Both without, Manus answered. May I ask Amit, why do you think that first one would be a hazardous scenario? Would you be comfortable to answer, Amit? Amit Karvande. No protections as such. Okay. And anyone in the case, maybe Manoj or Sujata, could you answer why do you feel that if there is no seat belt and no airbags, that would be more hazardous? Can anyone of them unmute and answer in that case? Or maybe type if you're not comfortable to speak. Okay, both are hazardous. Suraj Jagtap. Yeah, both are hazardous. We are just comparing which one is more and which one is less. I'll just give few seconds if someone answers, else I'll let you know. Okay, so the scenario is if you're not wearing a seat belt and an airbag deploys, the crash impact, what happens when a car hits, the first point of the car hits the wall and until the full car has come to stop, the timing of that is quite small. It is just around 70 to 80 milliseconds, which is really small. Even a blink of an eye is more taking more time than that event. So that kind of timing, in that timing, if the airbag deploys and you are already head on with the airbag, the airbag would just blow off your head, and there is high chance that you would die. You might not die if the airbag was not deployed. The reason being, airbag has a detonator inside. It is kind of a small bomb. So what happens when the signal goes in, it detonates. The detonation creates a gas which fills the airbag. So if you're not protected with the seat belt and your head comes in front, and at the same time when you're moving that fast, the moment of inertia of your head is so fast that you are moving forwards, and then on your face an airbag comes in, that causes more injury, and it would be most hazardous scenario than someone without an airbag just moving forward. He might be safe than the person with an airbag deployed and no seat belt. That's the reason, if you're not aware, but most of the times the seat belt works with the airbags. If you're not wearing a seat belt, the airbag will never deploy. The car is made such that if you don't have a seat belt on, there won't be any airbag deployed. So if you're wearing a seat belt, wear it the way it is supposed to, so that when the airbag is deployed, your head would be slightly further away from the airbag, and then your head would slowly go into the cushioning effect of the airbag, and you would be safe. So that's the reason uh, airbags and the seat belts work together. Hope I've explained and answered your question. Is that okay? Moving to another slide. Yeah. Seat belts are compulsory. Yes, seat belts are compulsory. Active safety, other things of active safety are adaptive cruise control, emergency braking, or the sensing systems, parking assist, the radar system. All of these come into active safety. Whereas if you go to the seat belts, airbags, body structure with program deformation, retractable steering column, all these comes into passive safety. That's why both of them are important in case to avoid the accidents. Moving to the next slide. So passive safety also concerns these structures that are important. So if you look into the side of the door, these are important in the side impact. There is rear bumper beam, which is important for rear impact. There is the pop-up bonnet. So this is one of the concepts, if you're not aware. If a car hits a man walking on the road, the bonnet would pop up, so that when the head comes on the bonnet would be flexible to avoid that head from getting injured. So that is one of the safety features, passive safety features that we have. And there are crush cans, there are front bumper beam, etc., just to absorb as much energy as possible. Now, this is the list of regulations that we have with respect to legal cars. So these are legal requirements, as well as there are some NCAP ratings. Each country has different regulations, and a car needs to adhere to those regulations when you are selling car in those countries. So most of the strictest regulations are of USA and Europe. So if your car passes these two criteria, most of the other countries are good enough for you. You don't have to test your cars in those countries, because the most stringent regulations you would ever see is in the USA and in the Europe. So you have legal US FMVSS, Federal Motor Vehicle System. So that is one of the governing body. And there is NCAP, which gives you star ratings. So you must have read that Tata has a 5-star car, or Mahindra has tested and they got a 5-star car. So these star ratings are also specific to a particular country. So US has their own star rating, Europe has their own star rating, China has their own star ratings. Each country has a good star rating. And I think India will be launching their star rating this year or next year, I'm assuming. But for now, they are testing into global NCAP. So global NCAP these are followed by few countries who do not have their own NCAP systems. So just to give you an awareness of all the regulations. So there are kind of three types of regulation. One is kind of legal regulations. So legal regulations means that if you do not satisfy their criteria, you can't launch that car in their country at all. So that is really important, that you need to satisfy the criteria of the legal requirement. consumer and insurance are not that mandatory. So if for example, if your NCAP ratings is not 5-star, if you are getting 4-star, 3-star, or even 1-star, but you are legal, then you can still launch your car in that country. So these are not mandatory, but people try to, or the companies try to achieve as many star ratings as possible. And there are some agencies called insurance agencies. Unlike India, in countries like Europe and US, the premium of car insurance depends on how they perform into this insurance ratings. So if to give you an example, if you're parking your car and you hit a pole or a wall with your bumper, and your bumper get damaged, so with that, how much is the replacement cost of that bumper, or how many parts of that bumper you're damaging in that test decides the insurance premium of that car. So most of those regulations are also important for many automotive OEM, because then the car won't be sold in that country, or most of the people would prefer to have lesser insurance for their car than higher insurance. So this is also more important. And there are OEM internal. There are some internal targets to decide for. It is company specific, so it has nothing to do with the legal or consumer. Okay. Any questions until now? Okay, thank you. So again, these are regulations. There's the list of numbers of the regulations based on the systems. Like for front, we have these regulation numbers that need to concern. So for pedestrian protection, which I work in, we have EU regulation, we have UN regulation, we have China regulation, and there is India regulation as well. So each of this regulation needs to be passed before we launch a car. So all these things needs to be taken care of when we are designing a car. And this whole system takes a lot of years until actual manufacturing happens. These are all done on simulation basis on the softwares and not on the actual vehicles. So just to show you, USA, if you want to have a legal car in USA, I don't know whether you could see the numbers, but I'll point you. There is first, which is 56 kilometers per hour flat frontal. If a car is moving at 56 kilometers per hour, there should be no injuries to the occupant as well as passenger. So there are dummies specific to male dummy, female dummy, kid dummy. All those dummies are being tested in these. So for US, as you can see, there are a lot of requirements in front crash. There is 56 kph. Again, there is with belt, without seat belt, those two test cases, and there is an angled plane. Also, there is an offset. Offset is in all the regulations. So offset means that if a car is coming in front and you are driving, so there is an offset or overlap of 40%. So that 40% impact happens. So these test is mandatory for all US, Europe, Japan, China, even India. And as you can see in India, there is no regulation for frontal crash. So a car, even if you have a car which is sold in Europe, can be applicable in India, because as such, we don't have any requirement for frontal crash. We just have a requirement for offset impact. And that is the only legal requirement for with respect to front. And with respect to side, you have 50 kph side barrier. So we have really less regulations in India as compared to other countries. And this is changing as of now. We are coming with new different test cases, new regulations for India, which would be more compliant. But since the Indian market is quite cost sensitive, because to have a car like this, you need to have a big bonnet, you need to have a lot of energy absorbing system. The car will go beyond 4 meters. And as you all know, beyond 4 meters, we have a different tax system for cars. All our cars in India, the most sold cars in India are below 4 meter or sub 4 meter, what we call. If you want to legally pass this, the car needs to be quite longer, and that would increase the cost of the car. And then again, the market would drop because people won't be able to afford it. So there are a lot of driving factors why we don't have the front crash safety as strict as the other countries. And apart from these, you have again pedestrian, rear impact, there is head impact. These are minor test cases. The major test cases are front, offset, and side barriers. So these are really important. And apart from this, there are slightly stricter ones, which are NCAP, where your star ratings are decided. These are on top of the legal requirements. So legal requirements are sometimes for bigger companies like JLR or Mercedes, BMW. For them, getting legal pass is quite easy because their cars are quite wide, they have quite good design structure, and they are expensive as well. The trick is to get 5-star rating, and this is really difficult because the criteria for 5-star is quite stringent than the legal ones. They have a lot of test cases. Each country has different test case. So there are, if you look for the cars which are launched in Europe and in America, there is a huge difference inside. You might see the car on the outside is quite similar, but inside there are components which are quite different for US, and they're quite different for EU and other systems. So all these test cases needs to be qualified to get a good 5-star ratings. Yeah. Do anyone have any question regarding this? Okay. So global NCAP, I'll just show 1 second. These data are freely available online. So if you go to Euro NCAP, for example, there is an EU NCAP website, and you can see all the cars with their star ratings. So for 2025, how many cars have been tested? What are the star ratings? How much is for the adult, the passenger, pedestrian, and the safety system like ABS, etc. And if you click on these, you will get all the data sheet separate. There is a PDF that you can download to view all those. Sorry, the website is blocked for me. But you can view it on YouTube as well. So for example, now this is something called leg impact. Now leg impact is divided into two aspects. One is pelvis, which is your hip bone, and this impactor represents a hip bone. And there is another where it is complete leg of a passenger, of a pedestrian, a person who is crossing the road. So from hip until the foot, you will have another impact. I'll just show you a video. Look into it. So you have certain requirements in this case to qualify. So these pelvic block, the force on the pelvic block should not exceed 5 kilonewton. So you have to design the front bumper system such that if this block is hitting at 40 kilometers per hour, the maximum energy, sorry, the maximum force that is exerted on the face of this impactor should be just 5 kilonewton or below. It should not go beyond 5 kilonewton. That is one of the targets. And there is another, a bigger leg impact after this. Yeah, so this is another, sorry. Let me pause it so that you can view. Yeah, so this is the pelvic block, like hips, and in the center, if you can see my cursor, that is the knee section. So this is all your femur or thigh portion. This is all your tibia and calf section, and even this is hitting at 40 kph. In this case, there is no force criteria, but all you check is the ligaments at the knees. There is the femur bone and the tibia bone. You check the movements of the bone so that the bone doesn't get injured. So that is all we test on this impactor. Just to show you video. So this is what happens to a person when he is hit by a car. And this is all in slow motion. In actual, if you want to see the actual speed at which it hits, this is how fast it happens. It's just quite small. It happens in just 15 to 20 milliseconds. That's how small the span is. You can understand how much important it is to get, assume in 15 milliseconds, you have to understand how the part compresses, how much energy it absorbs, and the person or the leg of that person should be safe. That is how critical it is to design all the bumpers so that it is taking the energy in that small time and also not damaging your leg. That is the kind of CA simulations that we do. Just going to next slide. Yeah. Oh, sorry. We have global NCAP. So even global NCAP, this is where our cars are tested. Our car doesn't, our Indian cars, they don't test in Euro NCAP. They would, sorry, we really didn't know that such kind of tests are to be taken. Oh, yes. Okay. Yeah. So in general, Indian cars are only tested for global NCAPs. And when you read the regulation, global NCAP is not that stringent. And we, when you say that we are getting 5-star ratings, you can't compare a 5-star rating for a global NCAP with the 5-star rating of Euro NCAP or US NCAP. Because if I take Maruti Suzuki, what is this, Victoris, it's getting 5-star. This would just perform 1-star or 2-star in Euro NCAP. So that's how lenient is the global NCAP. Does anyone have questions? Sorry, I heard some voice. It's just a background. Okay. So you can see these sheets as well. Download fact sheets and all. You can get those sheets. They'll show you how much each of them score. So when you're applying to buy a car, you can see the frontal airbag. Yes, it is standard driver. Yes, it has. So all these details are given. Do look into it because safety is really important. So when you're buying a car, you need to have a car which makes sure that you would be safe in case of any fatality. That's really important because this is not something that you would be thinking. Okay, if I met few people and they said that once the airbag is deployed, it is of no use. So I don't want an airbag. But that one deployment saves your life. That's what you need to think in that case. You should not think like, okay, once it is deployed, you need to put another airbag and that would cost so much. It's your life against the cost of an airbag. So make sure when you buy a car, you go through these ratings, read those, understand how they are performing at different speeds, different impact possibilities, and make sure that your car is quite safe, driving on Indian roads. Okay. So this is all about crash and safety. And I hope I haven't bored you enough. I mean, everyone is awake. Maybe a reaction would be good if everyone is okay for me to continue the further things. Yeah, cool. Does anyone have any questions?
Yes,
Yeah.
participants, if you have any queries, you may ask. I think no, sir. You may
No,
continue.
okay, that's fine. Completely fine. Okay, so all what you have known before was crash and safety. I was just giving you a understanding of how that market or that particular domain works. Now, this is related to actual job profession. This is something that if someone is interested, some of the students, yourself or some of your students are interested in these careers. So this is something that they need to be aware of. And this, the crash and safety testing, one thing is that you, once the car is built, you test it actually with the barriers and all. That is quite later stage of the development process, whereas there is the initial development process where you create a CE model and you test for those based on your CE material card, CE data, etc., and try to develop a car initially itself which would be compliant, and then you do smaller tests or lesser tests on the actual car. So that's the role of a CE engineer, first of all. So CE, computer aided engineering, most of you must be aware of. It's a derivative of FEM, finite elements method, which has it's an application base of FEM, to be honest. And some of them ask whether CFD is also does it come into CE? In a way, I can say yes and no as well, because some of the softwares are common to be used in CFD and CE, but CFD is something computational fluid dynamics, and it has the basic calculation principles are different from those of a finite element method. So I would be mostly focusing on finite element method based CE. So that is, there are three departments. One is crash, which I work in, crash and safety. There is NVH, which is noise, vibration, and harshness. and there is durability. So durability would be like you check the end life of product for n number of cycles, fatigue testing. Those kind of simulation comes into durability, and I'm focusing mostly on crash and safety because I think there is NVH is also quite tricky bit. Durability, I think most of the students of universities and colleges, they do perform loading for load deflection kind of simulation. So they are mostly same, but there are various load cases or test cases that need to be tested. You have road road loads coming in, fatigue testing for the springs and all, which are quite complicated coming later. But if you have questions, I am happy to answer. I would stick to crash and safety first. So again, in crash and safety, active safety is what comes into programming. Mostly software engineers would be there in this system, whereas passive safety is something related to mechanical engineering. So in passive safety, we have three different, uh, to be honest, two, but this is the third as a separate criteria used. So one is quasi-static. So we can't do static simulations in cars in most of the crash and safety simulations, and a few test cases are not fast enough to do dynamic simulations. So there are like seat belt anchorages. You check the strength of the seat belt, and since it is kind of a textile material, rubber textile material, so there is roof crush, there is another isofix something when if you have a kid a child seat and you fix it to those 2 points in the rear, so those are called isofix. So this simulation comes under quasi-static. Dynamic, you have frontal, as I've shown, pedestrian, the video you already saw seen, side impact, rear impact. Then there is structural safety, so you need to take care of structure. Most of these structures, like for example, door and all, should be kind of, I won't say it's safe, but after the accident, the door should be able to open in a good way. So those kind of structural system also you need to take care of. There is occupant, whereas a person sitting inside should be safe. Then again, you have in pedestrian head impact. One case, there is leg impact, rear is also structural, and interior impact, head impact. So interior head impact is something that uh, a, a person inside a car might hit different points on in the car, so they also test those things. So if the person's head hit on the IP or on the steering wheel or on the side, so all those are tested, and your interior of the car is designed such that if you hit there, your head doesn't get injured. So that is one of the criteria. So these department are quite specific. So each one can you select any one of it and make a career in that. So you have a lot of departments that you could work in. Uh, this is general process for any CA engineer. First is to prepare a model, pre-processing, what we call. So we use hypermesh most of the time in that case, or ANSA if you there are a few companies for durability that use ANSA. This is where you create a finite element model, or meshing, what we call, and develop a car or make a car with all spot welds, bolts, etc., all doors, windows, everything would be modeled. So that is pre-processing. Then you give boundary conditions, so that a test case, for example, boundary condition is the car is moving at 56 kilometers per hour and there is a rigid wall and it should hit it. So that boundary condition, once you create it, you give it to the solver. So for crash and safety, it's LS-DYNA that we use. There is another software called PAM Crash used by few companies, but LS-DYNA is more prominent in India. So if you so this solver would do all the calculations, what would fail, what would not fail, which is not visible for you. It will just run into computer. It will do its simulation, and then it will send out a file. So when a file is sent, there is another software for it to view. So that you do call it as post processing. So post processing something that once the solver has given you result, you open it in a software, view it, you can view the animation, you can plot the forces, you can plot the plastic strains, stresses, etc. And that's what you report in general. So this is the basic step of FEM in any department: pre-processing, solving, post-processing. That's all. Now, this is how we do. This is all the FE model, what we have. So you have closures. What do you call closures? Is something that encloses the car. So mostly it comes like doors, bonnets, tail door. That is into closures. We have bumpers, front and rear. subframes, you have powertrain system, you have BIW system, your steering system, you have IP system. There are dummies as well. You model the dummies for all these test cases. There are seat systems. So each and everything in the car would be modeled. There is nothing that is not modeled, which you won't see in the car. Even the wiring harnesses would be modeled to check the effect of it. I've just black and white it because this is confidential data, but just to show you, this is how we check. So this is an offset impact. This is full frontal flat impact on the rigid wall. And this is to check the airbag deployment and whether how the human head interacts, how the dummy interacts with the interior system. Okay. The side airbag, how does side airbag cover the person? As you can see here, when something hits in the side, the dummies or the driver or passenger is saved like this. It's a side pole impact. For example, when you're taking a turn on a highway at a higher speed and suddenly your tires don't have grip, it slips off and there is a pole or a tree, assuming a tree, it hits on the side. That's the kind of a load case that you're testing here. And this is interior head impact, as I explained. A human head inside the car, if it hits anywhere in the all these systems are designed such that if the head comes in contact, it should not be injured. And this is pedestrian head impact, where a person who is walking on the road gets hit by the car, so that head would come in and it would be saved. So even there is a airbag for the person walking on the road, he should be saved. So that's the system here. Cool. Yeah, so that's all from my side. Does anyone have any questions to ask?
Yes, participants, if you are having any queries, doubts, you may ask to Mr. Prateek, sir.
Hello, sir.
Yes.
Your session was really nice and informative.
Thank
If
you.
you don't mind, can you brief your journey from BE Mechanical to this position within 2-3
Oh,
minutes, if possible? Yeah.
yeah, sure. So I did my bachelor's in Walchand, Sangli. I had campus placement in Tata Technologies from Walchand. But it was slightly delayed. I didn't get immediate joining. It was a year later. So until then, I was just a lecturer in Kopergaon, Sanjeevani College. But yeah, once I started in Tata Technology, since I was a graduate trainee, I was given an option to choose the department, whether it was the BIW department or door systems or something like that. I chose, since I had few of my projects in college done in CE, I thought I would like to join the CE department. And again, as I showed in the slide, there were three open position. One was durability, NVH, and crash. It was not my choice, to be honest. I was just, we were three people in that team, so we were randomly allotted to individual departments. So I was allotted into crash and safety. So from Tata Technology itself, in 2014, I started my journey into first uh, working into hypermesh. So hypermesh is something that you just build models on, meshing tool. I didn't do the analysis for first around 1.5 or 2 years. I was just building up the models, and that is also an important experience, that you start creating model systems, because to develop a full car, it takes a lot of time. And luckily I got that exposure, that I started working, started building the models. First started with subsystems like seats or bumpers, powertrain systems. I didn't immediately start on building a full car, but subsystem wise, I gave few months, then started developing systems in car, and then I was brought into one of the JLR projects for roof crash, and somehow from there I just took a grab in these department, and I started doing simulations. Yeah. I mean, in a way, you could say that I was lucky that I got into crash and safety department. Yeah, but yes, I didn't aim to be into crash and safety, but I'm really happy that I was in crash and safety.
Okay, sir. Thank you. Thank you.
Yeah. Which simulation software gives the precise result for dynamic conditions? So LS-DYNA is what we use, and that is widely used software. There is another called PAM Crash, which is also good, but LS-DYNA has a lot of features that are more useful. And it has been occupied by ANSYS now. So ANSYS is the owner of LS-DYNA. You can go to their website and check that. Thank you. Thank you very much. Any other questions? I assume all of you are staff members?
Yes, sir. All are
Yeah.
faculty members from different and various engineering colleges, and some are from the industries.
Okay. Yeah. I don't know how it works, but there is. I'll just drop it in the chat. HyperWorks is something. HyperMesh and all those pre-processing software that you use. That is HyperWorks. I don't know whether they have it available for institutes, but they do provide student licenses. If your college is happy to at least to get a start in this domain, that would be really good, because there are a lot of companies who are I mean, there are a lot of new companies getting launched every year from China, from Vietnam, even from India, and these criteria are getting stricter and stricter. Safety is getting quite a lot of attention right now. So people would prefer to have safer cars, at least what I've seen in most of those countries. So there is a high chance that these departments would come in flourishing, because as of India, as I shown in that slide, we don't have any specific regulations for safety in the legal systems, which I feel in a year or two, these criteria would be stringent now. And once this happen, there would be a quite need of CE engineers. If you can, if the college gets those licenses, student software license at cheaper price, you can start grooming students in that direction. Even they can give you trainings, because since you're using their license, they have dedicated people who would help you in trainings and other bits which you can use. So yeah.
Yes, sir. We'll definitely proceed with this suggestion. So, any participant is there who is having any queries? I request
Yes.
participants.
Yeah. Sorry, I
Yeah.
just read the question from Tushar, Dr. Tushar. Yeah. Yes, I have. I'm working in one of those. I mean, it is not on road. It is still in development. But yeah, working on EV crash cars. Yes. So
Yes,
Rani
sir.
sir, I stopped you,
Yeah.
interrupted you.
Yeah. So I have the session. Question answer session is over. So thank you very much, Mr. Pratik Kakade, for such thought-provoking and engaging session. You not only shared your rich professional journey, but also you gave a deeper understanding how engineering, innovation, and safety come together in the real world of automotive industry. The way you explained the pedestrian protection systems, the bumper design, the testing methodologies, it's really helped us to appreciate the behind scenes of engineering that goes into saving the lives. Your discussion
Thank you.
on safety measures, crashworthiness, and validation technique open our eyes to complexity and responsibility of engineers that carries. So we especially value the way you highlighted the role of engineers in crash simulation, covering the both static and dynamic analysis, and how CA tools are applied in the crash model, the safety validation, the product development. So these insights showed us how theoretical knowledge transform into an impactful session or solutions that improve the safety of worldwide. So your expertise in this lightweight designing structure analysis, EV safeties, so has given the participant not just the technical know that how, but also the vision how engineering profession is evolving the modern challenges. So on behalf
Thank
of this organizing committee, all participants, we sincerely thank you for sharing your time, experience, and passion with us today. So
Thank you
on
very much. Thank
this,
you. It was my pleasure. Yeah.
yeah. So as we conclude today's session, I am sure we all are taking back not just knowledge, but a new way of thinking. The discussions today have and reinforced that the future belongs to those who innovate, collaborate, and adopt. So tomorrow we are continuing this journey with more enriching sessions. Till then, thank you everyone. Stay inspired and see you in the next session. Thank you so much. Thank you very much.
Thank you.
Hereafter,
Thank you. Have a great day all. Yeah.
yeah, thank you. So hereafter we are sharing the feedback link in the chat box. Please fill and share your feedback. We will share this in WhatsApp group also. So thank you everyone. Good night.